Hi, my name is Bob Grenier, and I'm a volunteer with the Martin Fleischmann Memorial Project. I want to thank Mr. Lin and Professor Huang and National Taiwan University for facilitating this talk and for allowing me to present to you all today. So I'm calling this Natural Balance. It's a follow-on from last year's presentation, and if you haven't watched that, it's available on the Martin Fleischmann Memorial Project's website. I recommend you go and view that because it's necessary understanding for this presentation. Okay? What you're seeing on the slide there is a sample of detritus that came out of one of Professor Huang et al.'s reactors. And you can see some shiny balls in there. And we are going to come on to those in a little while. So the cover slide for last year's presentation was this: working with nature. Possible nuclear reaction mechanism in water. And there is a leaf that my daughter found on the side of an Italian hillside, and she recognized the pattern. So, in my presentation that I gave last year, I made several predictions of the Huang et al. Reactors that, if true, I would be very confident that it was doing low-energy nuclear reactions. So my presentation was on the 13th of December, 2023, and I said that one, the fractal toroidal moment, FTM wheel within wheel within wheel, which I have this little symbol now, is based on a resonant magnetohydrodynamic driven coherent matter process. So we should see wheels within wheels within wheels if this is doing the process that I predict. Second, that it will produce from the bottom of the structure, so that is this part of the structure, a disruptive beam. Okay, you'll understand that more when you go and look at what I'm going to reveal to you today. Third, that strange radiation, SR, or coherent matter traveling waves, CMTW as I prefer to call them, will be present. That you will see iron-rich crenellated microspheres. These are very, very specific structures, and we're going to see if we see those things. And lastly, we should see transmutation in the form of electronuclear collapse, ENC, and in the form of electronuclear regeneration. And these are terms that were coined by Dr. Takaaki Matsumoto, who has unfortunately left us, and we'll talk about that at the end. So, the first samples were provided to me post that presentation 2 weeks later on the 29th of December 2023. And I did my first analysis starting with an SEM EDS from March 2024. Now, my current hypothesis for the whole process of LENR is this. Now, get ready. Multi-axis hydrodynamic shear in polar or charge-separated materials such as water or plasma will lead to fractal electrodynamic structures which possess fractal toroidal moments, a disruption zone, and areas of changed permittivity of the vacuum. The phase singularity and Aharonov bomb effect at the center of the fractal toroidal structure leads to coherent matter, even of electrons, and this is where we get into superconductivity, in the magnetic core and self-similar structures resulting in superconductor. Okay? It's in the process that it has to superconduct, not necessarily afterwards, but to achieve what it does. When fractions of the coherent matter at the core exceed their Schwarzschild radius, a black hole is formed. Electronuclear collapse can occur when the fractal electrodynamic structures fail. Matter is reborn into a range of common elements. So it's like collapsing matter into a new Big Bang and giving birth to a new little bit of universe. It's the flower of life. So I'll just read quickly from Dr. Takaaki Matsumoto's introduction to his book, for those that have not seen it. This was published by him, 200 copies, in the year 2000. Far in the universe, nuclear collapses very often take place by the gravitational force after stars consume their fuel. Since the electromagnetic force is about 40 orders stronger than the gravitational force, it should be easy to induce similar nuclear collapses by electromagnetic force in laboratory, but we never knew until now how to do that. Recently, this author, that's Dr. Matsumoto, discovered a nuclear collapse which was induced by electromagnetic force in laboratory. During studying of the mechanisms of so-called cold fusion phenomena, several kinds of nuclear reaction which were directly induced by the electromagnetic force called electronuclear reactions were found so far to occur in a special state of hydrogen clusters called atomic clusters or micro-ball lightning. The nuclear collapse was one of the most remarkable reactions among ENRs called electronuclear collapse. Furthermore, very amazingly, completely broken materials by electronuclear collapse were found to be regenerated again to thin tubes and films of conventional elements such as carbon, oxygen, and iron. The latter process was called electronuclear regeneration. And here is some products. This is from a lead sample. And on the lead sample, which is a tor with a hole in it, here you see what he refers to as eddy current type structures, which are related to magnetohydrodynamics. So his theory was that there was some sort of ring thing that went down to a point of electronuclear collapse, and from that you got like a wormhole that came out, and out of that became synthesized hydrogen, which you can't detect in SEM, carbon and oxygen on the outside, and on the inside, typically titanium and iron. Remember, titanium and iron as we go through this presentation. This is what Dr. Matsumoto observed. This, for me, is the phase singularity, which is at the point at which you get a topological monopole. That is the thing that does the job. So, I'm going to give you a couple of references here that are key to this. I did give most of these last year, but just to recap. This is a replication of work that was done in Japan in 1973. It was done in a major journal in 2021, funded by many of the national bodies around the world. And they found that in a femtosecond, or an attosecond, very, very fast laser pulse into a nonlinear plasma, they saw hydrodynamic structure. This is the projection there, and here you have 1.3 thousand Tesla. So do you have 36,000 Tesla coming into the center to a dead stop. Doesn't go through, it goes to a dead stop. And that is the phase singularity and the topological monopole. That's where the action occurs. Okay, that's the paper there. In this work, talking about toroidal electrodynamic structures by Afanasyev and Dubovik, in 1998, they say that within the center of the torus, you get the Aharonov-Bohm effect. This allows matter to phase synchronize. I talked about this last year. Required to do this is the formation of the monopole. And in the work of Bogdanovich at the Moscow Nuclear Physics Institute, they observed the production of monopole structures, topological monopole structures in water plasma flow discharge. And it produces these electrodynamic structures that glow and they last as a toroid moving around on metal for 2 days after the experiment has ended. These things are born and they have a higher binding energy than all ordinary matter. Okay? And this is the paper from 2008 by Wisniewski that proposed a Dirac-compliant monopole. And you can see that the electrons come in, they come into phase to a point, and this is the center, the magnetic center, and the phase singularity, the topological monopole. And it requires, for effectively a condensate of electrons to form, it goes down to a minimum radius, and that's a superconducting loop. So, this has been used in a patent, which is awarded to Lockheed Martin, and they do point electric discharges producing these electron solitons, and this leads to the formation of coherent matter, even of electrons. And they say it's absolutely critical to have the AB effect in play for this to happen, the Aharonov-Bohm effect. So what is the fractal toroidal moment, FTM? Well, I gave these two references last year, but just to go over them again, prior proposals for action of the extended Maxwell electrodynamics. One, In this paper, Schwerblis, 1995, this was referring to classified Soviet research in the energetics field in the 70s and 80s, maybe even earlier. They worked this through by looking at extending Maxwell equations, and they suggest in this paper that the electromagnetic phantom that is produced, and I can explain that later for those that are interested. I have detailed this in many presentations before, but it can potentially capture photons from vacuum fluctuations. This means it both polarizes the vacuum, creates positron-electron pairs, and those annihilate to produce 511 kiloelectron volt photons, and it captures them into this electromagnetic phantom. Okay? So that's capturing energy from the vacuum. Second one is vacuum currents by Freiberger. These are both looking at ball lightning structures. Okay? Remember, Matsumoto said this is microball lightning. Ken Shoulders says this is ball lightning. It's a natural phenomenon. How does it work? These people are working to that. He said by extending the Maxwell electrodynamics, a similar kind of treatment that was done by the colleague of Schwerblis, you can end up with a critical phase transition where the Dialdi angle, as he calls it, leads to decay of baryons. That's protons and neutrons. Okay? So right now, we have low-energy nuclear reactions, both fission, fusion, and transmutation. We have capture of energy from the vacuum, and we have the complete decay of matter. If you have a proton decay per nucleon, it's 133 times more energy than you get from nuclear fusion. It's way, way, way beyond fusion. So you only need a minuscule amount of this to occur, and you create a lot of energy. Minuscule amount. Right, so what is the toroidal moment? If you have an electric current going around in a loop, you have a magnetic moment. If you take that, rotate it 90 degrees, and put at least two of those in a loop, you end up with what's called a toroidal moment. You take that, rotate it 90 degrees, and you have what's called a hypertoroidal outside of Russia. They call it supertoroidal in Russia. I call it fractal toroidal. Because the other terms are like supermarket and hypermarket. They don't make any sense, but fractal does. Okay? And you can keep doing this, and on and on and on. This is the wheel within a wheel within a wheel. So, in a presentation that I gave in Italy, 28th of September 2022, named this, specifically targeting ultrasonics, I showed this slide, which was from German work, and you can see you have these two similar structures mirrored. For this to be a yin-yang, it needs to have a wheel here and a wheel here, making this wheel. And that is a wheel, and that is a wheel, so you have a wheel within a wheel within a wheel. Okay? And also, you have it again here and here if these are a pair. Okay? That is the magnetohydrodynamic structure, the fractal structure, and I'm representing what we've got here, and you have a phase singularity at each of the fractal levels. So this is the n-level fractal topological monopole zone. This is the n-1 zone, and you'll have an n-2. And there's different magnetic pressures in each. Now, I've only done a 2-2, which is similar to this structure in the bowl structures, and that's mostly what you seem to be getting in your system, and I will show you that. So, self-similar nested vortex, whirlwind and tornado. The tornado, the vortex, the whirlwind, is the only structure in nature, the only structure which is negentropic. It is the basis of all life. You have an emergent tornado from here, but that is made by two tornadoes, and they are made by two tornadoes. So the tornado and the ring soliton that creates the tornado is a chicken and egg situation, but this is how life begets life. It has a phase singularity topological monopole. So here is a 3D structure, here is the 2D structure, showing the yin-yang, exactly and precisely and correctly in a normal hydrodynamic flow. Here you can see the 3D structure, and because of the combination of the electrodynamics here, you end up with what's called a non-radiating boundary. Outside of this, there is no electromagnetic waves being propagated, only scalar and vector potentials. There are communication technologies based on this being developed right now by one Hal Puthoff at NASA for communicating with submarines. Okay? He actually has a patent based on this from 1993. He's extending that patent, but he doesn't refer to that patent currently, right? Okay, so you can see that I've showed the wheel there, like this wheel here, and then I'm showing the little wheel in there, which is like this in itself, and so on. So again, that's why you get this. Okay, now, in that same presentation that I gave in 2022, I showed this mainstream paper in Physical Review B from 2014, okay? And they're calling it hypertoroidal because we're in the West. That's what we call it in the West, okay? And they say you can change, by changing the aspect ratio on your hypertoroidal structure, you go from a ring up to almost a sphere. And if you change the polarization by a number of megavolts per meter, you end up with a vortex one way, and you end up with a vortex the other way. And they're looking at this for next generation data storage, okay, and communications, as I said before. Now, be ready to have your mind blown. Because what I'm about to show you on the next slide, it freaked me out when I saw it in Huang et al.'s Reactor. You ready? Boom! Oh. How is that even possible? This is a yin-yang pair, and in it has a yin and a yang and a yang and a yin. They are a pair that have pairs inside them, and you're going to find out that they've got pairs inside them. This is utterly mind-boggling levels of data. Look, that's what they predict on a nanoscale from mathematical predictions. This is what you see. And look, that's 10 microns. These are physically massive structures. Right, this is also on your reactors. There is the magnetohydrodynamic structure. Note, it is exactly and precisely as it should be. It's not guesswork, it works exactly like this. Note, this is a 20 micron scale, and on the next, this is from the DHX2 reactor. On the next slide, I will show you the same scale, but the outside of the structure, the N-level wheel, this is the apple of it, by the way, it's the apple structure, that will be blown off, and you're going to see what I call the fat Oreos inside, and they're going to be these parts. All I have done is change the image, and I've moved this up to where the next structure is. Watch this. Boom! These are the internal structures, exactly and precisely as they should be. Not slight guesswork. Nature does this exactly.
So that one, green one, is the singularity one?
That is the outside. There's various event horizons. You have an event horizon here, you have an event horizon here, here, and it depends how much it's spun up. And what it'll do is, if it gets too strong, it'll split into the next level of quantized structure up. It's absolutely incredible, the data that you have facilitated here. Thank you, Mr. Lin. Okay, so look, watch. Bang! Now it's not just there. What they try to do when they collapse, this tries to fold on itself. You can see that that one is in 90-degree orientation. It's trying to fold round there. It's ejecting, because as it's dying, it's ejecting the material that it captured into its phase singularity. Over here, there is one, and it's basically lost the other one, but look at this. It's got where the hole is. Can you see it? Absolutely mind-boggling data. Look, this is an apple, like the one I showed you here. That's an apple. It's two apples. This is a next order structure up. Look, this is an apple, and it's burst here as this died, and the bits from the inside have come out. That was the wheel, and the wheel that was inside this wheel, the apple. Okay? Look at the next one. Watch this, watch this. This is a massive collapsed structure that hit the surface. There's the golden ratio number here to the point of destruction. These are the N-1 structures that came out, and from this one it burst, and you've got an N-2 structure come out. That was the wheel, and that was the wheel that was in this wheel. This wheel and this wheel was up here. Utterly conclusive data. Utterly mind-boggling levels of www data. Thank you. I missed one. Right.
Exciting.
This is the most incredible data I've ever witnessed, and I'm only just beginning. Disruptive beams. This is an apple, and its tornado, just like a real tornado, because this is the same thing that occurs in real tornadoes and does all the magic of tornadoes, touched down up here. And as it touched down, it was pulling in copper from the surface. This is why you don't want a too high COP reactor, because it'll destroy the metal, right? It's pulling in, and as it's pulling in, you can see the path is getting wider. It's such an incredible disruptive field. It is literally tearing spin 63 and 65 copper out of the solid metal. And as it's pulling it in, it's also pulling itself down. So it's like engaging with the surface, and it's crashing into the surface, and it embeds in the surface. Incredible levels of data. Now look at this. This one has died. And all of the matter that was captured inside the phase singularity, where the matter becomes coherent, so you can keep having the same atoms occupying the same space-time, right? It emerges in a reverse tornado. And this, my friends, is stellar synthesis nuclear material. It's born material in the same kind of proportions as you get, the same elements you get coming out of stars. I would argue that this is the process that runs stars, not hot fusion. Cold fusion is what runs stars. Here, that there is a toroidal vortex of copper that's being sucked into the disruptive beam. Mind-boggling. And here is ejecting stellar synthesis. Right, strange radiation tracks, coherent matter traveling waves. This is from Matsumoto, 1999. This is from Neil Crichton Gold, 2018. This is from Alexander Parkhomov, 2020. All cold fusion experiments. All cold fusion experiments. Look at this. This is Dr. Roy Shinamaza, cavitation on a steel plate. Cavitation spot. Twisted pair vortex coming from one side to the other. Now you can't see this unless you use polarized light. Why? Because the intense magnetic energy trapped in the middle causes the arrangement of the nuclei so that it changes and bends light when it touches the steel. And that's why you can see it with polarized light. This is from a cold fusion experiment by Dr. Matsumoto, palladium deuterium, okay? Early 1990s. This is the fractal toroidal structure, and it's broken up, and some of the structures have come out. You're literally seeing on an X-ray film how this process works. But we've got better than that. We have caught it on camera. This is a ball lightning, and it's blowing up, and your ejection of your coherent matter traveling waves is coming out. I've blended frames together there. They also interact only with each other and don't care about the anode and cathode. So, this is Roy Shinamaza on a steel plate in cavitation. There is the only visible by polarized light, coherent matter traveling wave shadow left in the steel, instantly as it traveled through. Here, you have 4 frames in a plasma reactor of David Bullier in Canada. Coherent matter traveling wave. What you're watching is the persistence of vision of the camera across 1, 2, 3, 4 frames, and I've merged them together to show the beam. Okay? That is the collapsed coherent matter wave from a Henk-Uren experiment. This is a woven diamond. Helical beams weaving around each other. Now look what we found in your reactor. This is one structure that died, and the material inside has left a woven structure of stellar synthesis material. This is not contamination, my friends. It's not contamination, not contamination. Something magical is going on here, and it's life. This, my friends, is another structure, and it's crashed in here, it's come along here, and it started to destabilize, and this is actually an N-1 level TOR section. And it's collapsed here, leaving N2, N-2s that wove this braid of material that are captured inside. And over here, this N-2, it sent out a helical beam that way. Oh my God! This is my favorite image of the year. It's the most important image I think we could find in this data. That's a close-up of it. It's mind-boggling data. Here is another example. A structure crashed there, a pair. They broke up and one came down to here and one came down to here and it actually goes off the frame, right? Look at this. I'm going to focus in on this. That is a few nanometers of copper ripped from the copper pipe. And it's in a wave, 1, 2, 3, 4, 5, 6, 7. I think this had 24 subsections around it. Torn, and it's torn from this level to this level. What is this? This is where you get sunspots on the sun. From this point to the point down there. It's mind-boggling what this is showing. It's almost unbelievable to me, and I've seen it a lot of times now in this data. Look, there you're seeing the 3D structure on the secondary electron. Right, iron-rich crenellated microspheres. The signature, in my view, of natural ball lightning, of plasma produced when a meteorite comes into the atmosphere, of many, many experiments that we've done in plasma and water cavitation. This occurs in what I call the small box. It's actually this hollow sphere, okay? And there's hollow spheres here. It's what I call a smaller box, but it's actually not a box. It's a sphere, okay? And this is the disruption zone, the point of disruption. This is in a Henk-urine plasma reactor experiment. You have your caduceus, one of the oldest symbols known to man, coming into the point of the phase singularity here. You can see the cup. This is exactly as the caduceus is drawn on coinage 300 years before Christ in Macedonia. Okay? This is from Samaria, and it's like 11,000 years ago. From that, a structure ejected and it came down here. It was there and it flipped over. This is the ejector from the pole. That pole would have been there with the material going in to the disruption zone. That there is the point, the phase singularity, the n level a topological monopole. Here, that's the Chinese found this and published in Nature, I think, or Physical Review, the spectrum of ball lightning. Here is a synthesized ball lightning in the Henk-urine experiments, iron-rich crenellated microspheres, stellar synthesis material in the broken up field around it, and then here we have silicon dioxide, and on the outside you have calcium oxide. Almost all of the Earth's crust is those elements. This is in Adamenko's work. He ran the Proton 21 lab outside of Kiev. He did 10,000 successful consecutive experiments. And this is his patent drawing, where he says, in this pure copper plate, an iron-rich sphere is produced that has a hollow interior. In the center of that, matter collapses and dark matter takes part in the process. Just what I told you last year. This is from his 2003 patent. This equipment was moved to Illinois in 2015. It was verified between 2015 and 2017. The site went dark and it was transferred to Brookhaven National Laboratory as part of the National Fusion Program in the US. This is in an arc discharge experiment, a crenellated sphere. This is in a microwave plasma experiment. Hollow, you've got a sphere here with a hole in it in one end. This is in an ultrasonic experiment done by my colleague Alan Goldwater in America. This is one of the iron-rich crenellated microspheres produced in 900 seconds. It has silicon dioxide on the outside because that's what's the next thing on the outside. Because if you fuse two silicon, you get iron, by the way, right? And it has these crenellations and then this coherent sort of glassy layer, and then this is the inside. So this is a broken up structure. And you can see it's triangular, a bit like this triangular section here, okay? This is in a plasmoid reactor by Malcolm Bendel. This is a hollow sphere in the plasmoid reactor of Malcolm Bendel. This is your material, Ben. Now watch this. This is in your reactor.
Where is the superconducting?
It occurs to make these things, you need the superconducting field. It doesn't stay as a
where it happens? In singularity?
There's no singularity. Mm-hmm. Not in the whole universe.
And
There are these things making black holes.
And where are superconducting?
Scale invariant.
Where is superconducting?
It occurs to make this magnetic core. The electrons come in through the Ehrenhof-Bohm effect, and they produce a superconducting ring, and that produces an intense magnetic beam. And that's what's doing the work. It's producing the topological monopole, and that's what's doing
So
the
the final product has no superconducting.
Well, I don't know. That needs to be investigated. Maybe it has some latent superconductivity. I don't know. Do know these things don't rust. You gave this to me a year and a half afterwards. There's no rust at all on it. This is not the formation of rust. How is this possible? It was living in water. Not at all rust. It's a special ratio of FeO2, it would seem, which was only discovered in China in 2017. And it required 1,700 degrees in a diamond anvil at ridiculous pressures. That means if this is this material, the pressures in there are gargantuan by the electrodynamic structure.
So I think Bob, the transformation here is, the form of superconductivity.
Yes.
And then you form, and then in order to
Yes.
set all those magnetic field, and then separate material into that form.
Yes. You basically create unlimited amount of electrons. Well, it gets to a point where the strength and the density of energy exceeds the Schwarzschild radius, so neither light nor matter can accept. Only things can go in until the overall electrodynamic structure dies because of some instability, or it doesn't get fed enough electrons, and then it dies.
So to find this kind of in corresponding acceptor, what's the temporal scale? We do know the spatial scale, but what's the temporal? This one will picosecond or the...
These things, the yin-yang structures in a normal $35 ultrasonic cleaner start getting formed in 8/43,000ths of 1 second, right? Because this isn't what I showed you earlier, where they're putting an incredibly high-powered laser into a nonlinear plasma. You've got a polar material. And when you spin a polar material with easy water, it starts creating electrodynamic structure, magnetohydrodynamics. And that becomes fractal very quickly.
Right.
And because you keep feeding it a little bit of energy on a resonant standing wave and phase conjugation, so you get like one wave like that and another wave like that. And so you get a node and you get an antinode. And so it transverse to that, you get the yin-yang forming, okay? It happens on the surface. And if you look at Piotr Kapitsa, the Nobel Prize winner for discovering superfluidity in liquid helium in the 1930s, he won it in the 70s or something. In 1954, he wrote on the subject of ball lightning or something, on the matter of ball lightning. And he says when his hypothesis, a microwave hits the ground, it gets reflected, so you get phase conjugated waves, and transverse to that, you get the ball lightning formed. So this is consistent with everything we know about magnetohydrodynamics and extended electrodynamics.
So that exactly perfect going to fit into the system designing, cavitation, that one, the frequency.
Yes.
That one typically will cost.
I will show you what I believe made some of Bin's reactors very effective.
Okay.
This is in Bin 1 work.
Yeah.
We not only have a cracked iron-rich crenellated microsphere, we have the material still stuck inside, and it's got soliton structures. And this is the synthesized material. Transmutation. Again, the point of phase singularity, topological monopole, this is the point that collapses the matter, the electronuclear collapse. This is not a singularity. It's an area, and it's very specifically based on the sacred geometry. This is in a Henk-Uren experiment. You can see an iron-rich crenellated microspheres, and there's two tori structures coming out. But as it was dying, it was laying down this predominantly carbon trail. This is what Matsumoto found. You look into it, look what we see here on the structure here, titanium, 11.3% by weight. What is titanium? It's the fusion of CO2.
Fusion.
The fusion of CO2. Now, I'll tell you a little thing. I analyzed some material from Zatalepin and Baranov. They had an exploding discharge in a sealed chamber with a glass fiber, optical fiber going around it, passing a low 5 milliwatt or something laser. It produced a beam into a CO2 chamber. You know what happened? Where that beam went into the CO2 chamber, there was a trail of white powder formed underneath it. And when I analyzed that powder, what did I find? I found aluminium, which is CO fused, producing aluminium and hydrogen. Huang et al. Controls. These are the controls I received from you in May. It's always good to look at the controls. So you've got your solder on the left, and you've got your outer and inner tube. What do we notice on this inner tube? Can anyone see it? Anyone see what's on that inner tube? You know, so I'm not going to ask you. Anyone see it? What do you see on this inner tube? No? It's rifling.
There's right.
Yes.
Inside.
Yes. So as water's traveling down between the outer tube and the inner tube, it's got hydrodynamic shear here this way, hydrodynamic shear this way, but it's also got second order hydrodynamic shear. You are forcing the construction of these structures. You are forcing it. It's a happy accident. Here is your solder. In total, you have carbon, nitrogen, oxygen, small amount of phosphorus, copper, and silver. Here is your outer tube. You have carbon, nitrogen, oxygen, and copper. Here is your inner tube, carbon, nitrogen, oxygen, a little bit of chlorine, and copper. Okay? Right. Here is your samples. Get ready, guys. Get ready. That is your inside tube, and you can see all of these structures. Here's the rifling, and when you look at this with enough time, you'll see that many of these structures have started to aggregate in the bottom of the troughs of the rifling. So as the fluid is coming up onto the top, it's producing a vortex, and there's a slow area below, and it's depositing these structures. Thankfully, because this few millimeters that I analyzed has thousands of these structures that you've been seeing earlier in the presentation, you're going to see more of now. There's a yin and yang structure, and look at these fibers coming out of the structure, but they're entangled with each other. These particles are entangled. Now, when this is live, these magnetic flux tubes will be going between them, but you can't see it. They're wormholes linking these two things together. This was observed in Ken Shoulder's EVOs. He could split up an exotic vacuum object, and they would go through the material, or they would separate into multiple pieces, and then they would snap back together when they could.
So this kind of like a quantum entangled?
They're entangled through a magnetic flux tube, right? And you could pull these things apart. You can see it in Bogdanovich's work. He sees in a water flow plasma discharge a monopole at one end and a monopole at the other, and there's a flux loop. You see it in the Malcolm Bendel reactor. The flux tube comes out of the steel into free air and back in from the steel, and it's just mind-boggling to see this nature at work. Now, what do you see here? This is a subtoil that's blown out of something else, and there's a fiber that's come out of it. All of that material fitted in here. This alone proves, this one image proves that there is coherent matter going in there, that there is a phase singularity. Here, all of that material, all of this is stellar synthesis, all of that material bursting out of here. Look at this one. That is the one that's just split open, and you've got the entire amount. It like burst, right? And here's your elements. Look at your elements here. All of the stellar synthesis elements. Yes, we had a little bit of chlorine. Yes, we had a little bit of phosphorus. And we had copper. And we've got water. But look what we have. We have sulfur, calcium, aluminium, magnesium, potassium, iron. Look at this. This is a broken structure, and you're literally seeing the dead internals. This is aluminium coming up here. You have copper and phosphorus on two of the tores, which are part of the substructure. Here, iron-rich crenellated microsphere, typical. Here, this is, without doubt, a spectacular piece of data. This is regenerated matter, like the one that I just showed you before, and it's broken the shell, okay? And here, this is, the structures come on the outside of the ball, of the core, and this is golden ratio between the glassy section on the inside and the crenellated section on the outside. This drives all of the golden ratios in your body and in the nature. Look at that. What is in the core? 22, nearly 23% titanium, fusion of CO2 in toroidal solitons. Just like you saw coming out of that plasma reactor. This is in water. Nuclear reactions in water. Look at this. Isn't that beautiful? Just like Matsumoto showed, from the inside of this structure, it's burst out through a wormhole and it's born this beautiful crystal of newly synthesized material. It's the flower of life. Look at that. Two structures that happen to intertwine. This is my conclusion. Samples from the reactors evaluated show all of the expected signatures of my hypothesis as proposed prior to receiving any samples. Coherent matter-traveling waves are being produced that may include relic neutrino clusters that could produce further excess heat if leveraged correctly. So out of this, you're getting collapsed matter, and it produces a beam of material. And this has been verified by looking at a guy called Griffin Brock. He's produced a replication of a Tesla shadowgraph tube, produces beautiful X-rays at 22 feet away. Not as harmful as X-rays, producing, because it's co-limited beams, you don't get any diffusion, you get incredible images out of this thing. And on that electrode, just over a week or two ago, I found the magnetohydrodynamic structure perfectly represented. And in the core, you get the stellar synthesis of elements just like you find in your materials. I'd like to thank my dear colleague, Alan Goldwater, who allowed me free use of his SEM for about a week to look at this material. You can see the two money shots on there, the Apple structure, the magnetohydrodynamic structure, and the internal structures on there. This is a really proud moment for me. And thank you, Mr. Lin, for making this possible. And thank you, Mr. Huang, Professor Huang, for all you've done. And I'd like to also make people aware that there's about 2 or 3 days left. I'm producing the family gave me 142 kilograms of materials from Dr. Takaaki Matsumoto. We will be sharing all of the logbooks, all of the analysis logbooks, and videos that he took of his experiments, and updating everything with color images from the original negatives and original things. So if you want to grab a picture of that, that would be great. And you can get a digital version for $30. So I'll give you a second.
Is it Amazon? You buy from Amazon?
No, I'm doing a Kickstarter, so it's a social funding program. So yeah.
So just give you, and then you send the book, or?
No, you go to the Kickstarter. The PDF will only be available to people on Kickstarter. Okay? And you'll see many, many things that we've observed in the Huang reactor. I'd like to thank all these people, the contributors to the MFMP, the researchers and volunteers that have worked with the MFMP, my colleagues past and present, especially Matthew, Ryan, Alan, Henk, and Sho, supporters of my personal blog at remoteview.ico, and some major donors, Charles, Stephen, Goran, and many of the donors, big and small. So with that, I will say, it's been a real pleasure and an honor to have the opportunity to be the one to look at these samples. Thank you. Any questions?
Bob, I really appreciate it, because you have the recorded, I think 3 hours, like YouTube, regarding all the SEM and FDS, and I watched that one 3 hours, and then you have done great analysis. I watched all the video, and then you show this one, some pictures you already showed in that, the YouTube. I think you've done a great job to link that information together. Before, if I see that one, I have no clue. Mm-hmm. But after you give me that books, I read that books, mm-hmm. and then from your lecture, mm-hmm. now I understand. Not 100%.
Yeah,
it's okay.
Try to learn. It's okay.
But I understand now why you're saying that one, and then those learn from nature balance. Yeah. And then just suck in and regenerate mm-hmm. the material. Without the nuclear reaction, that's not going to happen. The image of the technology that runs the universe is in our faces. That's right. So and it's mind-boggling that in the yin yang, or the omega and the alpha, these are all symbols of how the technology works. And I don't know how ancient people knew it. But it doesn't matter. They did. Someone did. They were getting very lucky with their guesses. This is far more important than just superconductivity. You understand that this is the flower of life. It's how nature works. And you proved it in the samples that you gave me.
Yeah, from your presentation, you mean that there's a superconducting process
Yes.
during
Necessary.
during-
Absolutely necessary.
necessary. That means fusion process, including superconducting process.
It's matter coherence. You're creating magnetic pressures 5 orders of magnitude stronger than the
So the
center of
superconducting.
our sun, Sol. The same magnetic pressure that you would get inside a pulsar. This is by Lutz Jaitner. He's done the calculations on a 5-micron structure. So you are literally creating neutron star level pressures inside your reactors.
So that's a superconducting.
It has to be.
Has to be.
It has to be electrons
So-
in coherence.
So what kind of material involved in superconducting process?
Sorry, what?
Material involved.
The electrons.
Oh,
They form Cooper pairs and they come down. Look. That's right at the beginning. Yeah, there's too many slides. Getting there, right at the beginning. There. It is electrons which are out of phase. You have a magnetohydrodynamic structure set up by the resonant fluid dynamics, the hydrodynamics in the cavitation at resonant nodes. This forces charge-separated material to focus and then cohere at a point. So you've got out-of-phase electrons. They come down to a point, and if we expand this up, it ends up at a particular distance. They can't get any closer. But once they're here, they become bosonic. They become Cooper pairs and then bosonic, and then you can keep feeding electrons in there until it exceeds the Schwarzschild radius, and you get an analog of a black hole. There's 3 astrological models for a black hole, and each of them are mutually exclusive, and they're all wrong. This is what's going on because this is scale invariant. It's scale invariant.
You mean the superconductivity takes place during the fusion process.
To enable all of the processes, not just fusion, fission, transmutation, electronuclear collapse, electronuclear generation, regeneration after it dies, capture and formation and capture of vacuum fluctuation energy, 0-point energy, and baryon collapse.
And what kind of medium?
Water is the best mains.
Water. All happens in
It's
water.
already polar. And when you start spinning polar, it organizes itself into
Nothing
an
to do with-
electrohydrodynamic structure. And that leads to this formation.
So what you mentioned is all happens in water.
It can happen in water. It happens in plasma. I've shown you plasma and water systems, not just by you. I've shown water systems by us.
So nothing to do with material, for example, copper pipe, something like that.
The copper pipe is useful for several reasons. It is a spin nuclei. So it has 63 and 65, and it's highly conductive. So on the surface, you get a high level of conduction electrons. So if you've got, when you have a sound wave, and you've got an anti-sound wave, the phase conjugation is automatically on the surface, because that's where the wave gets reflected.
Yeah, you have a conduction band, you're allowed.
Yeah, you have a sea of electrons on copper. Silver would be better, but you can waste as
Anyway.
much silver as you like. Copper's good.
Copper is just acting as a
It's an electron donor.
boundary effect.
It's an electron donor to the process.
But anyway, all the process happens in water.
Yes, it happens in plasma.
Like
but
in water.
I mean, it
That's
happens
very
in metals,
important.
actually, because metals is actually a solid plasma. The electrons, the conduction electrons, it's a weird bond, it's a metal bond, and the electrons are flowing around. So you can do this with sound, and NASA have done this, and so has sorry, he's gonna hate me if I can't remember his name. So it's some Italians, they've done, just put sound into metal, and they see these toroidal structures and transmutation in the middle, just by putting sound into metal. But it's so much more efficient because you don't have to put the energy in to make the plasma, because the water is already polar. And when you start spinning the polar material, it creates the electrodynamics. And the electrodynamics are what drives the process of the formation of micro black holes. which are the structure that provides the energy to ball lightning, which is a natural phenomenon. This is what the fusion reactors are trying to do, and if they ever achieve it, it's going to destroy the reactors. If they ever make a working reactor, it's going to destroy the reactors. It'll consume the reactor.
OK，我们讲不完了。
So, but they in the heavy water, but now just the regular water, and then.
The reason you get, let's take an image here. Right. Electrodynamic structure is trying to pull things in.
Yes.
If it's a magnetic beam, what is it going to prefer? Well, it's going to prefer paramagnetic or magnetic materials, or spin materials, right? If you have a strong enough magnetic field, nothing will be resisted. It'll make it come in anyway. But you're in water, right? So what I showed you here, where is it? No, I'm going forward, backwards rather. Here, I showed megavolts per meter, right? If you look at this structure and the scale, this works out at 7.2 electron volts. Positive, the positive-negative differential. That is more than enough to split water and to split H2. And atomic hydrogen is paramagnetic. H2 is not. So you make the structures that split water and then they feed on the split water.
So would you think, if we heavy water and regular water, use heavy water will be better,
Yes, because what happens is, okay. What happens is, oxygen, all forms of oxygen are paramagnetic. But O2 is 16,700 and whatever times more paramagnetic than atomic hydrogen, right? So it's a unique gas in that it is so paramagnetic. So it gets sucked in, right? And then you've got the atomic hydrogen that is synthesized in the process, that gets pulled in. You've got the dark matter going in there, just like has been claimed was part of the process by Ken Shoulders, as claimed as part of the process by S.V. Adamenko in the hollow iron-rich cores that he saw, okay? And in there, they fuse to oxygen-17. And when you get oxygen-17, it's now spin nuclei. So it's more preferential to go back in than any of the oxygen-16 or oxygen-18. You understand? The process accelerates, and it makes a stronger and stronger structure. It's beautiful. And when you look actually at the formation of galaxies on the Hubble Space Telescope, they have this north monopole and south monopole, and in the center of the forming galaxy, what do you see the spectrum of? Oxygen.
17.
Oxygen, probably 17. It's the same spectra though, right? If you want to give yourself a difficult job, try and find the difference between oxygen 17 and oxygen 16 spectrum.
Oh, 17, very important.
It's going to be oxygen. It's incredible. It's all through nature. And your data nails it. I predicted what you would see if your process is working in the way that I've seen in other systems. And you nailed every single aspect.
Anyway, everything happens in water.
Yes. Yeah. This is happening when water is trying to work its way through a crack in the ground, making hydrothermal water, which is very good for you because those elements are new. They've been synthesized as the water was coming through and cavitating. When water is going down a stream producing cavitation, it is producing new elements. That's why life likes to live in a fast-running stream. That's why the salmon like to spawn upstream, because there's all of these new elements there. That's why life likes to live near a shore, because the water's crashing on the shore, making new elements. It's beautiful.
So in linear process with water, there's no reactant like a chemical reaction. Water creates nuclear reaction. Nothing to do with reactant.
The polar nature of water through hydrodynamic shear, and in your case, because you use wonderfully spiraled tubes, more hydrodynamic shear and multi-axial hydrodynamic shear leads to the electrodynamics that do the magic that someone must have known a very long time ago.
But anyway, originality comes from water
Yes.
reactions, fusion in water.
It's not just fusion, it's all of the above. It's everything that creates life. It's everything that creates life, and it's even black holes. You're making little black holes, and you're letting them die.
And the reactor design just help
Yes.
the reaction.
So it will produce etheric matter streams. What do I mean by that? There are three components of matter. There is the electrons, there is the nuclei, which can be from a proton upwards, and there is relic neutrino clusters. Okay? And these can be in the form of neutral clusters, which are just what the Russians call magneto-toroelectrical radiation. And when you add ions or electrons, you get positive or negative net charge magneto-toroelectrical clusters, which are exotic vacuum objects of the charged type, of the white type. And these are synthesized. Now, you may be losing these, and you can benefit from those by introducing things like potassium into the reactor, because potassium is synthesized in the reactor, but you want potassium-40 component, the 0.02% or whatever it is, potassium-40, because that can release high energy. Or around your copper pipe, as I told you in May, you add in things like lithium fluoride. Lithium can, with the interaction of this material, and fluorine with its spin nuclei nature, can be either trapped and pulled in, or it can synthesize heat outside. And in the work of Dr. Alexander Parkhomov, he found lithium fluoride produced the most excess heat outside of the generator of the strange radiation. So you can take your pipes, put materials around it, and you might massively increase the amount of heat you can produce, because you're not wasting this fraction of matter that comes out.
Yeah, it's about time to. I think we have to end.
That's okay.
Okay,
that's okay. If anyone's got any questions, also I have so much data. It's not just 3 hours.
Okay.
I've got hundreds of hours of data, many videos.
5 minutes rest. Okay.
Okay.
But I think that 3 hours, the analysis is really great. I watched I watched not only one time, a couple of times. To absorb what you're saying,
It's called flux capacitor. If you go to the MFMP's YouTube channel, it's called flux capacitor. It's the one where I have my colleague here. Where is it? Right at the end, Alan Goldwater. Oh, I'm right at the beginning now. And I really mean flux capacitor. It stores magnetic flux, and it gets stronger and stronger and stronger until it can affect nuclear transmutation, zero-point energy harvesting, and matter collapse. And bearing in mind, if you get CO2 forming, you get 5 electron volts, right? If you get hydrogen forming per nucleon, that gives you 4.62 electron volts. That's the highest energy you get from any chemical reaction known to man, right? If you get uranium-235 splitting, you get about 201 million electron volts. Divide that by the number of nucleons, it's about 1 million electron volts. If you take deuterium and deuteron and you fuse them to 4 helium, you get something like 26 or 25 mega electron volts. That's about 6 mega electron volts per nucleon. If you take one 938 million electron volt proton and you do baryon collapse, that was predicted by Freiberger at the SLAC Institute 2009 in a ball lightning, using extended Maxwell electrodynamics. You get 930 million electron volts per 1 nucleon collapsed. Divide that by 6, you get roughly 133 times more energy per reaction. It's ridiculous. And that is the opportunity that you're tapping into. You only need to hit it once in a blue moon, and you get a lot of heat out.
Yeah. Okay.
Oh, and by the way, last point is this. The reaction occurs in here, and an electromagnetic wave cannot escape here. So you do not see the radiation. You only see it when these structures die. You see a little blip when one of these blows up, because that's when it's escaping. Inside here is a different space-time. It's literally a different permittivity of the vacuum. It's a different universe.